For years, battery engineers believed electric vehicles faced an unavoidable trade-off. If you wanted ultra-fast charging, you sacrificed battery life. If you prioritized longevity, charging became slower. And if you pushed both, safety became the biggest concern. The industry called this the impossible triangle, a balance between charging speed, lifespan, and safety that no commercial battery had fully solved. Now, one Chinese automaker claims it has changed that equation. Geely has unveiled what it calls the Golden Brick Battery, a lithium iron phosphate or LFP battery already installed in the production version of the Lynk & Co 10 sold in China. According to the company, this is not a laboratory prototype or a concept vehicle. It is a commercially deployed battery technology designed for real-world drivers. Its headline specification immediately captured global attention. During official testing described in your source material, the battery reached a peak charging power of 1,093 kilowatts using a 900-volt electrical architecture. Geely says the vehicle can recharge from 10% to 70% in approximately 4 minutes and 22 seconds, a figure that places it among the fastest charging production EV systems announced to date. But speed alone is not what makes this announcement significant. Fast charging has historically accelerated battery degradation because rapid energy transfer generates intense heat inside the cells. Excessive heat damages internal materials, shortens battery lifespan, and increases safety risks. Solving one problem often creates another. Geely argues its battery overcomes this challenge through several engineering innovations, working together rather than relying on a single breakthrough. The company highlights a 12C charging capability, a self-healing SEI protective layer, and an S+ active coating designed to stabilize the battery during thousands of charging cycles. According to the company's published claims, referenced in your source material, these technologies allow the battery to maintain performance for 4,500 full charge cycles, potentially translating to a service life approaching 1 million kilometers, depending on vehicle usage and operating conditions. If those figures prove sustainable in long-term, real-world operation, they could reshape how consumers think about electric vehicles. Instead of viewing battery replacement as an inevitable long-term expense, drivers may begin to see EV batteries as components capable of lasting through the practical lifetime of the vehicle itself. Yet perhaps the most surprising part of this announcement is not how quickly the battery charges, it's how Geely claims it remains safe while doing so. That may be the company's most ambitious engineering challenge of all. If ultra-fast charging is one side of the equation, safety is the other. And this is where Geely makes some of its boldest claims. The launch of the Golden Brick Battery comes as China prepares to enforce one of the world's strictest electric vehicle battery regulations. According to the company and the source material, the GB 38031-2025 National Battery Safety Standard requires battery systems to prevent flames and explosions for at least 2 hours after thermal runaway begins. It also introduces tighter thermal management requirements for LFP battery packs during charging. Geely states that it completed certification of its vehicle lineup ahead of the regulation's implementation timeline. Managing heat is essential because charging at more than 1 megawatt generates enormous thermal stress. To address this challenge, Geely says the Golden Brick Battery uses a dual-sided liquid cooling system, predictive battery management software, and a redesigned internal cell structure intended to distribute heat more evenly throughout the pack. During the company's charging demonstration, it reported battery temperatures remaining around 64 degrees Celsius, staying below the temperature threshold referenced in the new safety framework. These performance figures are company reported and would continue to be evaluated through independent real-world use over time. The company also showcased several extreme durability demonstrations, including crush, penetration, and ballistic resistance tests designed to illustrate the battery's structural integrity under severe conditions. Such demonstrations are intended to highlight engineering resilience and should not be interpreted as representing normal operating environments or everyday consumer use. The announcement naturally raises comparisons with BYD, another Chinese manufacturer leading the global EV market. While Geely emphasizes charging performance and battery longevity, BYD continues expanding its high-power charging ecosystem alongside its well-known Blade Battery technology. According to your source material, Geely currently demonstrates competitive charging performance in controlled testing, while BYD maintains an advantage through the rapid expansion of its charging infrastructure and strategic partnerships. In practice, battery performance and charging convenience will ultimately depend on both vehicle technology and the availability of compatible charging networks. Perhaps the biggest question is what this means for the future of battery innovation. For years, many experts viewed solid-state batteries as the next major breakthrough in electric mobility. But if advanced LFP technology continues improving charging speed, lifespan, affordability, and safety simultaneously, manufacturers may have greater incentives to continue refining existing battery chemistry before transitioning to entirely new systems. Whether the Golden Brick battery ultimately proves to be a genuine turning point or simply another step in the rapid evolution of EV technology will depend on long-term independent performance. What is already clear, however, is that competition inside China's electric vehicle industry is accelerating innovation at a pace that is reshaping expectations for the global automotive market.